Hi again, everyone. Today we're going to do another chemistry lesson, but this time it's going to be an electrolysis in the unit of electrochemistry. Yay! That's one of my favorite units. I love it. It's electrifying. We're going to rock and roll today. Party time. Okay, now you know how they always ask you about what's the mass or grams deposited of a metal when they're electroplated with a certain current in amperes and a charge in coulombs, and then you need to, sometimes your teachers have shown you a big stoichiometry where you have to go from one to another, one to another, and to another. I'm not gonna go that route. I'm gonna show you a simple formula which will always work, okay? So bear with me. It looks complicated, but it's really not. It's gonna be a lot of fun. Basically, to get the mass of the metal deposited, what you need to do is find the equivalent mass, times it by the charge in coulombs, and divide it by the Faraday's constant of 96,500 coulombs. Once again, the mass deposited is the equivalent mass times the charge in coulombs divided by 96,500. Now, the charge in coulombs, as you know, is the current in amperes times the time in seconds. Remember from class? Once again, charge in coulombs is current in amperes times the time, which must be in seconds. Equivalent mass is the molar mass of the metal divided by its oxidation number. Once again, equivalent mass, as you'll see, will be the molar mass of the element broken down from the compound and divided by its oxidation number. Okay, got it? So let's do a problem together and we'll get it. How many grams of calcium are produced by the electrolysis of calcium bromide at 30 amperes for 10 hours? So I'm going to give you a little bit to copy it first. Okay, so basically we need to fill all this into the formula and then we'll find the mass deposited. So let's start with, the equivalent mass. The whole compound was calcium bromide. It's going to be broken down into calcium plus 2. Remember from the units previously learned in naming compounds, where ionic compounds, the charges are swapped and they're dropped and when they become subscripts. So calcium gets a subscript of +2, and there are 2 bromines now. However, it gets a subscript of -1 because it's a nonmetal which gains electrons, so it's an anion, okay? You got to review that unit for naming compounds and you'll see that the charges are swapped and then dropped, okay? So, in this instance, we'll see that calcium, if you look on the periodic table, calcium has a mass of 40 grams. Now, divided by its oxidation number, which is 2, and you get 20 grams. So that's going to be our equivalent mass. Got that, my friends? The molar mass of calcium divided by its oxidation state of 2, which is going to give you 20 grams. So that's going to be the equivalent mass. Now, the charge in coulombs is going to be the current in amperes, which is going to be, in this case, 30 amps, times the time in seconds. So what you were given a time in hours, right? So we have to convert that to seconds. So it's 10 hours. 1 hour is 60 minutes. And 1 minute, 1 minute is equal to 60 seconds. So times everything and you get 36,000 seconds, okay? So the current in amperes is, current in amperes is going to be 30 amps times 36,000 seconds. So get out your calculators and do the math. And we'll see that it's 1,080,000 coulombs. 1,080,000 amps. I'm sorry, coulombs. Uh, so that's gonna be our charge in coulombs, okay? Now, so note these things down. We're running out of space. However, I'm gonna just write it down on a notepad and we're gonna work with this here and get our answer, okay? So once again, the mass deposited is equal to which was our equivalent mass of 20 times the charge in coulombs, which is 1,080,000 coulombs, okay? Divided by 96,500, which is Faraday's constant. So let's do the mass and find out. I love chemistry, it's so fun. And altogether, you'll get the mass deposited is equal to 224 grams. Voila! Simple, right? Now, these problems are really basically it. Sometimes they'll ask you for the grams deposited. Sometimes they're going to ask you for the current. All you need to do is just plug in the formula. Remember, mass deposited, once again, is always going to be equivalent mass times the charge in coulombs divided by 96,500. Equivalent mass, like before, as I mentioned, is equal to molar mass divided by the oxidation number, and charge in coulombs is equal to the current in amperes times the time in seconds. And of course, there's 96,500 coulombs, which is always going to be Faraday's constant. So, once again, I hope you understand. I hope you had fun today. I hope you enjoyed it, and always enjoy chemistry. Learn to love it. It's the best thing in the world. Thank you.